Hello everyone. So from today we are starting a new series on low level design or LLD. In this series I will be explaining all the important design patterns as you can see on the screen. So before we start, I would like to explain that design patterns are mainly of three types: creational, structural and behavioral. And all the design patterns we see are one of these kinds. So the creational design patterns, as the name suggests, deals with the object creation. मतलब जब भी एक new object create होता है, in such cases these design patterns comes into play. Then we have structural design pattern, which deals with how the classes and objects are arranged. And then we have behavioral design pattern, which is basically how the objects communicate with each other. So today I'll be going through the Singleton design pattern, and later on we'll go through each one of them one by one. Okay. So to start with, I'll take an example. Let's say we have a database, and whenever we have a user, we create a new connection to that database. Let's say we have a user 1 and we create a DB connection for it. Then we got a user 2. So for that also we create a new DB connection and so on. So in this case, the problem is that whenever we get a new user and we create a new DB connection, it is very resource heavy and it will slow down the system. Also, most of the databases have a limitation on the number of connections we can create. So let's say if the limitation is 100 connections, and if we get more than 100 users, then it is not possible for them to connect to the system. So it is unnecessary duplication, and also it will affect the consistency of the data in the database. So the better approach for this would be that beforehand we create a DB connection, and whenever we get a new user, we assign that connection to all the users. Whenever we get a new user, we assign the same connection to that user. So this is basically the crux of Singleton design pattern, that Singleton means only one object should be created for entire application. That is, create once and use everywhere. So I'll go through the code. Let's say we have a class called Singleton. Right now it is a normal class, so we can create multiple objects of this class. I'll show you how. So we'll write Singleton s1 equals to new Singleton, and we create one more object, s2 equals to new Singleton. And to verify, we can check that whenever we create a new object, the object which is getting created are different. So we'll compare these. I'll quickly run this code. See, false. So whenever we create a new object with a new keyword, the object which gets created is allocated a different memory. So s1 is not same as s2. That's why we got false. Now, as per this problem statement, we don't want this. We want only one object to be created for this class. So for that, first of all, we will mark the constructor of this object as private. Now we will not be able to create a new object of this class using new keyword like this, because this method is now private. And you must be wondering that initially we did not had any constructor in this, then how we were able to create it. So the thing is that by default for every class, compiler itself provides a default constructor or a no argument constructor, so we don't need to write that constructor, and it is public by default. So now we have made it as private, that's why this will not work. I can show you. You see, it is private, so we cannot. Now we have solved one problem, that we cannot create multiple objects of this class. Next is, but at least we need one. So for that we should control the object creation in this class itself. So I'll create a variable private static singleton instance. This variable will store that object. It is static because we want this to be shared among all the classes, and it is private because we don't want direct access of this instance, otherwise other classes will manipulate this object. Then we will write a method public static singleton get instance, and in this method what we will do is we will check if instance is null. That means currently this object is not created. In such case we will create the object, and here we can create with the new keyword because this is private to this class. So here we can create instant equals to new singleton. Otherwise we will just return the object. So what will happen? In any case, if the object is already present, if this is already created by some other class or method, then this will not be null and instance will be returned. And if it is null, that means nobody has created the object yet, so we will create a new object and return that. So now once we will run this, and we cannot we need to use the new method we have created, get instance method. We will singleton dot get instance, and we'll do the same in s2. And that is why we have kept this method as static, because so that we will be able to fetch it or call it from the class name. Now in this case it should be true. See, we have got true because in this case only one object is getting created. Now this is pretty straightforward, but what if we have some class which is having multi-threading? In such cases this will fail. This will not work, because in this case whenever two threads enter this block of code at the same time, for both the threads instance will be null, and in such cases two objects will get created. This will create a race condition and singleton will fail. So in such cases we'll have to slightly modify this code and add a synchronized block. So till here it is fine, but after this, once we have checked if instance is null or not, we don't want this to be executed by all the threads simultaneously, so that only one object is created. So for that we can add a synchronized keyword dot class, and inside that we can put this, but before that we can again check if instance is null or not. Okay, this is double checking the locking, because initially once we have checked instance is null, it is possible that after this instance become non-null and we are entering with a thread. So double checking is important after synchronized, and synchronized keyword basically ensures that whatever is inside this block, for that only one thread can enter this block at a time. And one more thing we need to do is this variable we should make this variable as volatile. Volatile will ensure that this instance is visible across threads, and the latest updated value of this instance is available for all the threads, because it is possible that once one thread updates this instance value and creates a new one, it is possible that the other thread uses, so there is some caching principle in this. The other thread might be using the cached value, so volatile ensures that always the latest value of this instance is used by all the threads. Now this is now thread safe. I will write the code, so we cannot will create threads. I'll write a thread class for this, and sorry, public void run okay, and then we can just simply print this. So let's print the current thread. Dot get name plus let's print the object as well to ensure that same object is getting created. And then we can create multiple threads. So let's say my thread t1 equals to new my thread t2 equals to new my thread, and let's create one more, my thread t3 equals to new my thread, and I'll start all the threads. Start t2 dot start, t3 dot start. So in this way, what we are doing is we are making sure that each of these threads are basically this class is thread safe, and each of these threads will create only one instance of this instance of this class, singleton class. So I'll quickly run this. So you see, when we are printing the object, all of them are same objects. And अगर यहाँ पे हमने synchronized add नहीं किया होता, in such cases it is possible that multiple threads would have entered the same block and multiple objects create हो गए होते. तो यहाँ पे अलग objects, there is a possibility, मतलब it's not sure that it will create different objects, but there is a possibility कि same object create होते. So today we learned how to create a single object and reuse it. Next we will do the factory design pattern tomorrow, or builder or factory tomorrow. That's all for today.